Hello everyone, here's Ivan Fedorenko, and today we're starting the next big section of our course. Not just a weekly model, but a 4-week section on data analysis. Before that, throughout the last 12 weeks, we discussed different types of data that we can collect from online sources from digital media. We talked about website and app data collected through Google Analytics and other web tracking systems. We talked about social media data collected through social media channels, social media listening, and analytics. And we talked about search data coming from search engines on users' search behavior. Now, the question is, what do we do with this data? And one crucial element of data-driven management is experimental mindset. The beauty of digital marketing is that it provides opportunities to try and test different ways of doing things, to compare them and decide which one is better. What's experimental mindset? Imagine, well, you're organizing a wedding, maybe your own wedding, and you have a discussion with your fiance. You think that green tablecloth is better, but they are quite confident that the blue one is preferable. How do you resolve this issue? You try them both, of course. You set up 2 tables, make one green tablecloth, another one blue. You think about what's your outcome. What are you trying to find out? Is it the amount of, I don't know, alcohol consumed at the wedding, or amount of wedding gifts you collect from that table? Then you randomize, so every guest has an equal chance of being at the green or blue table. At the end of the day, you collect the data and you compare who drank more and who gifted more. That's how you know. Next time around, when you happen to organize a wedding, you'll be very confident in saying that, hey, I tried it out and the blue table works best. That's what experimental mindset and data-driven management is at its best. Why do we need experiments to decide which course of action is better? Because anything that we know, anything that we think that we know, isn't true. Absolutely, there's now no truth in the world. We gotta adapt everything. You think that your company performs not as well as you think it should because your prices is too high. This is not true. That's a hypothesis. It's a guess until it's proven, tested, and supported by data. How can you support it by data? Change your price. Maybe at limited scale for a limited market, try it out and see if this little market with another price performs better. Essentially, there can be no discussions and no opinions in business. No one is entitled to have an opinion. Whenever we have different opinions, different courses of action, or any kind of discussion, what we do? We experiment. Just like that boy. He doesn't know which costume will bring him more candy, so experiment. That's what we do. In this example, our New York Times has adopted an amazing experimental mindset and practice. When we visit a web page of New York Times, what we see is an article title and a little lead, a few sentences presenting this article. New York Times, as a publisher, needs us to read article, need us to read as many articles as possible, and spend as many times as possible on the website so that they could serve us ads and make money from ads. To achieve that, they need us to click on the article, on the title. The outcome variable, the outcome they want to achieve, is a click. How do they do that? They experiment by testing out up to 7 versions of each title. So for each article, New York Times crafts 7 versions of the title. For example, about the SpaceX test launching of a Mars prototype rocket. They create 7 titles and they randomly show different titles to different website visitors for several hours, and they measure click-through rate. In this example, you see that version number 5, the yellow one, receives the highest click-through rate, 24%. It works so much better than other 6 versions. So after several hours, New York Times concludes the experiment, and from that moment on, they use this proven best title. In marketing, we very often use experiments to measure return on investment from marketing. Because return on investment is such a complicated topic. We know that return on investment is essentially what we gained from investment, subtract what we spent, and divide it by what we spent. But what do we gain? What have we gained from marketing effort? It's so hard to figure out and attribute revenue and financial outcomes to marketing activities. Just like in this example on the right, this person thinks that if their customer clicked on mobile advertising, that means they can attribute all sales of running shoes to mobile advertising. Is that so? What happened before that last click? That person would never be convinced to click on mobile ad if they hadn't seen the mailer, the billboard, the search ad, radio ad, and TV ad before that. That's a difference between a last touch attribution, where someone attributes revenue to the last touch we had with customer before the purchase, and actual marketing mix modeling, which quantifies the value of each touch point and tries to figure out how much each touch point, each ad on the consumer journey contributed to our revenue outcome. Calculating return on marketing investment requires us figuring out and calculating first what is the actual impact, a financial impact of marketing activities such as advertising or content marketing or influencer marketing on the financial result. We gotta be sure that this activity actually caused that result, that we gained revenue because we did something right on marketing side. Not due to good weather, not due to holidays coming up, not due to customers being in great mood after the elections or being sad after the election. No, we gotta make sure that what caused our overperformance or underperformance was actually our marketing action. And I emphasize the word cause there because now we're talking about causal effects. Causation, where one thing causes the other. Establishing causal relationship is hard. It's not enough to calculate a regression or run a statistical test and see that, hey, variable X is related to variable Y. So we know that what we did results in the outcome. Because it doesn't. In many cases, statistical relationship, statistical analysis is misleading. For example, in this example with ice cream consumption and number of sunburns, we get data set on ice cream consumption, we get data on sunburns, do statistical analysis, and they're closely related. Does it mean that eating ice cream creates sunburns? Doesn't. No, it doesn't, because there is third variable, unobserved, not included in our data. Hot, dry, sunny weather, which causes people to eat more ice cream and causes sunburns. We just cannot see it, but that's the actual cause. That's how limited data can lead us to misleading assumption until we can establish a true causation. Statisticians use this famous motto on correlation doesn't imply causation, which means seeing these two things related doesn't necessarily mean that one causes the other. The graph below shows beer consumption in the United States and the percentage of populations feeling lonely over the years. As you can see, beer consumption goes down year after year, and the feeling of loneliness goes up and ever up. The obvious conclusion here, right? People drink less beer and they feel more lonely. So we probably just need to force them to drink more beer. They will be happy and less lonely. Won't they? Probably not. These things are completely unrelated to each other. There can be a third variable, like mental health crisis or TikTok addiction, that makes people feel less connected to their friends, spend less time with friends, and more time staring at the screen with TikTok videos. So they don't go out and don't drink beer. Another of my famous example, pretty easy to understand for everyone, is example of school ratings. Everyone wants to live in a good school district with highly rated schools. Why? Because somehow in our mind, we as resident citizens and consumers have this idea that if my kids go to the highly rated school, they will study better and perform better academically. That's why I need to rent or buy a house in a good school district. That's how we think. But is it true? Not necessarily. It is a hypothesis. In fact, think about it, how exactly school ratings can improve student performance. A rating is just a number on a website, 7 or 8. What does it mean? How can it affect actual student in the classroom? If they're studying the same material, same common core math, using the same textbooks, the same assignments, and taught by pretty much the similar teachers, both graduated from Cal State East Bay. What actually affects their performance is their parental income, because highly rated schools attract wealthy families. Wealthy families invest more in extracurriculars, in after-school tutoring. They invest more in their children's education, and that investment in parents' wealth improves student performance. And student performance improves school ratings. School ratings don't do anything. They depend on performance created by parents. This allows us to talk about three things necessarily to say that one thing causes the other, to actually establish causal effect. One, to start with, yeah, it's necessary. Statistical correlation, statistical link between two variables. I have school ratings, I have student performance, I ran the regression analysis or statistical test and see that they are related. There's a connection between two variables. If there is no statistical connection, there's nothing to talk about. But if there is a connection, we need much more to say that connection is causal. First of all, the cause should happen prior to the result. In our example, school ratings and student performance. Students study, students take tests first, and then based on test results, district gets school ratings. Performance and tests happen earlier, before ratings. What happens earlier, before, is more likely to be the cause. And the third important thing is we're going to be sure there is no third variable that explains both observed variables. Just like with case of sun, ice cream consumption, and sunburns. We're going to be sure that there's no alternative explanation. To make sure that there is no alternative explanation, things called word non-spuriousness. To make sure there is no such explanation, we're going to be able to explain how exactly one variable causes the other, how exactly school ratings affect performance. Know-how. There is no mechanism for a number on a website to affect performance. If we look at it the other way, hey, student perform better on the tests, and that creates ratings. Now we can see the mechanism. And when we see the mechanism, that allows us to confidently say, hey, one thing causes the other. They're not just related to each other. There's actual causal effect. Good thing, I'm not sure if it's good thing or not, but pretty much the only way of establishing causal relationship is experiment. Because in nature, many things happen all at once, simultaneously. And there is almost no way of excluding potential alternative explanation, excluding third variables. If we just collect data from online sources, from our apps and websites, we will never be able to say that, hey, our website traffic jumped because we changed something on the website. Because it could have jumped for a million different reasons, completely unrelated to what we did. In contrast, when we experiment, we know that we hold all other things stable. We isolate and control everything but our action, and we change one thing, making everything else steady. That allows us to say that our action caused the difference in outcome. Of course, there are comprehensive statistical modeling methods. If you ever have a chance to take econometrics class at college, do it. Don't think, just click enroll. Because econometric modeling is a statistical way of establishing causal relationship without experiment. We can do it, but it's hard and not very reliable, not completely reliable, let's say so. Econometric modeling tries to establish causal relationship by calculating a hypothetical would-be result. We change taxes, and our consumer spending and economic growth and rate of unemployment changed. How do we know if the change in taxes caused that outcome? We try to model would-be result. What would have happened if we didn't change the taxes? And then we compare reality to this hypothetical would-be model. And the difference between those is the effect of our action. Just on this graph on the left, you see that economic growth changes over time. In green and red line, just goes up in state A and state B. Then state B, the red state, changes their taxes, the state level taxes. And the economic growth jumps. So we don't just compare two states, we compare actual economic growth of red state B to would-be hypothetical economic growth of the same state. Dashed line over there. That's how we know the causal effect. But econometric modeling is the second best thing to do. We only do it if we, for some reason, cannot run experiments, if we cannot experiment. Just like in policy, it is impossible to experiment with taxes, just change taxes temporarily for half a year and then return them back. Or change taxes in one county for 1 week and another county for another week. It is impossible, let alone think about healthcare and changing healthcare policies and procedures, risking our population health for the sake of scientific exploration and experimentation. It's impossible. So in these cases, econometric modeling is the only way. But if we actually can experiment, if there is the slightest possibility and opportunity to experiment and test different versions, different policies, we must do it.